Okay, so that one got a little lengthy, so how about we break this one down? Again, it's just keep manipulating data, all right? So, but first, just kind of analyzing what we have here. B is equal to a half. So that means my new period, right, is 2 pi divided by a half, which makes it 4 pi. So we are we are horizontally stretching it. So the period is getting longer. We're taking our sine graph and stretching it out. The D is equal to pi over 4, right? And so we're subtracting it, so that means we are moving to the right pi over 4 units, right? Subtraction means the reverse of what you think. So we're taking all our x values and we're eventually going to be adding pi over 4 to them to get that shift over to the right. But again, order is important. So how do we do this? We manipulate data, right? So for a sine graph, here's our basic, oops, got ahead of myself, right? Here's our basic points on a sine graph, and we're going to be manipulating them. Order is important, so what I'm first going to be doing, let me highlight this in red, is we are going to be dividing everything by a half. But if I divide everything by a half, that means I'm actually multiplying by 2. So when I multiply everybody by 2, the x values that is, the y values are not being manipulated at all, but all the x values are being multiplied by 2. So 2 times 0 is 0. Pi over 2 times 2 is pi. Pi times 2 is 2 pi. 3 pi over 2 times 2 is 3 pi. And 2 pi times 2 pi. 2 pi times 2 is 4 pi. So again, you see, right, 0 to 2 pi was the normal period, but it's been stretched, right, 0 to 4 pi. So the graph has been stretched out. But now what we got to do is account for the phase shift. So I'm now going to take all these x values and add pi over 4 to every single one of them. Sorry about that. The sun's kind of getting into that picture there. All right, let me shift it over. Okay, so this is where our math comes in. So this one's easy, right? So x, y, these haven't changed, but pi 0 plus pi over 4 is pi over 4. Pi plus pi over 4, well, this will be 4 pi over 4 plus pi over 4, which is 5 pi over 4. So that would be the next data point. Okay, 2 pi plus pi over 4, well, this is 8 pi over 4 plus pi over 4, and that's basically 9 pi over 4, right? 3 pi plus pi over 4, well, that's 12 pi over 4 plus pi over 4, which is 13 pi over 4. And then last but not least, 4 pi plus pi over 4, well, that's 16 pi over 4 plus pi over 4, which is 17 pi over 4. All right, and so when it comes to graphing this, how about I do it down here? So I kind of ran out of room. Right, so we're still bouncing between 1 and -1 along the y-axis. All right, so that hasn't changed at all. And then to scale this, we have pi over 4. We have 5 pi over 4. We have 9 pi over 4. We have 13 pi over 4, and we have 17 pi over 4. And so the graph, right, starts at 0, pi over 4, 0, and then 5 pi over 4, 1, and then 9 pi over 4, 0, 13 pi over 4, -1, and 17 pi over 4, 0. So there's this new graph over one of its cycles. To compare this, 9 pi over 4, right, the 2 pi would be roughly about right there, right? And so pi would roughly be about here, right? And so what we end up having, right, so a normal sine graph doing all its action, right, would probably look like this eventually. So you can see that the graph has been stretched out and then shifted over pi over 4 units in terms of a comparison. So we can definitely see the stretching, and then we took that stretch and we moved it over, all right, and I guess 4 pi would be somewhere right in there, right? So there's 4 pi. So we went from 0 to 2 pi, we've stretched it out from 0 to 4 pi, and then took that graph and stretched it over. And that's kind of what we did we manipulated that data. So again, I think it's kind of hard to manipulate the picture, in my humble opinion. It's easy to do the math on the data, and that's why I've been doing that since we've been doing this, even in 4.1. Take your core values and manipulate the data the way the transformations tell you to do. Divide, multiply, add or subtract depending on the translation we have. Do it to the data. You will be able to sketch at least one good period for this thing, and then getting 2 periods and 3 periods will come along. But if we can just get one, that's half the battle. All right, so now we're going to truly put it together. So we've handled what happens when we have a sine of a b x minus d. So what happens when we throw an a and a c in there? Well, we're going to put it all together. Of course, these guys now impact the y values, and we just basically keep them separate, do our data manipulation, and hopefully you guys will see it's that easy if you can do all the additions and whatnot. So I'll see you guys then in those next videos.